Lewis structures or dot structures are a very useful tool for chemists to be able to model the valence shell electrons of a molecule, showing how the electrons are distributed around the molecule. To begin a Lewis structure, we first must identify what molecule we are modeling and how many valence electrons each atom in the molecule has. Let's say we're modeling CO2 or carbon dioxide. How do we find out how many valence electrons each atom has? It's relatively easy if you use the periodic table as a reference. First, you must find the element on the periodic table, then look above at the group number. The last digit of this number is how many valence electrons each atom has. So in our case, carbon is in group 14. Thus, it has 4 valence electrons, while oxygen is in group 16, meaning that each atom has 6 valence electrons. So we add up these totals and get 4 plus 6 plus 6, which equals 16. This number will be very important, so it is best to write it in a place where you can see it. After we find the amount of valence electrons in the molecule, we are able to begin the Lewis structure, which is composed of dots and lines which each have a separate meaning. The dots, which are found in pairs, represent a lone pair of electrons. So a pair of dots represents 2 electrons. A line between 2 atoms represents 2 shared electrons, a way of signifying a covalent bond. The beginning of this structure is crucial as the atoms must be in the right places. A good rule to go by is that the first element in the formula is the central atom, unless it is hydrogen, as hydrogen cannot be a central atom. In our case, we would put carbon as the central atom. Then you must surround the central atom with the other atoms in the formula. But as with most rules in chemistry, there are some exceptions, as if there's a hydroxide in the molecule, in which case the hydrogen would be connected to the oxygen instead of the central atom. At this point, after we have the basic structure of the molecule, is where the 16 we wrote down earlier comes into play. We need to find a way to fill each atom's octet while only using 16 valence electrons. The octet is the valence shell of each atom, and to have a full octet, each must have 8 valence electrons. This could be 3 lone pairs and a bond, or maybe 2 lone pairs and 2 bonds. To start the Lewis structure, draw bonds represented as lines, connecting the central atom to the other atoms in the molecule. With the bonds drawn, you will subtract the number of bonds times 2 from your original amount of valence electrons. With this remaining number, you will add lone pairs to your outermost electrons represented as 2 dots. You will continue to do this until the number of valence electrons, including those within bonds, contained in your structure is equal to the total number of valence electrons you calculated before, in our case, 16. This is a crucial point in the creation of the structure. If all the atoms in your structure have a full octet, say for hydrogen as it can only hold 1 lone pair or 1 bond, then the Lewis structure is complete. If not, you have to rearrange the electrons and bonds to fit the criteria. In our case, carbon doesn't contain a full octet, but we don't have 4 extra electrons to complete it with. So instead we take a lone pair from each oxygen and form a bond with them, thus completing the full octet. It is important to remember that if you convert lone pairs that are on one atom to a bond, the total number of valence electrons stays the same for the molecule, but it increases for the atom that is bonding with the original, in our case, carbon that is bonding with oxygen. As I said earlier, with everything in chemistry, there are exceptions. In some molecules, there are more than one valid Lewis structure, where the only difference is where the double bond or triple bond is held, such as CO3. These are called resonance structures. If you are asked to model a molecule with multiple valid structures, you should draw them all. In reality, these molecules are never found like any of the resonance structures. Instead, their bonds are averaged out. So in reality, the oxygens are bonded to carbon in CO3 with a 1 1/3 bond strength. There is also such thing as an expanded octet in larger atoms, such as xenon. In creating these Lewis structures, you should go through all the normal steps that I explained earlier, but at the end, if there are extra lone pairs or atoms, these are all attached to the central atom. Once again, this was JNA Chemistry. I hope this video was able to help you. Have a nice day.